So in my previous video, I explained how warbling happens, and I've done that by connecting my two waveform generators up in series. But kind of the downside to that is you can only see one signal at a time, so you couldn't really necessarily see how the two signals were interacting. You could just kind of imagine. But this oscilloscope will actually take up to 4 inputs. So I can have both of the inputs plotted, and in fact I do, up here, and I can do math on them. So I can take channel 1 and channel 4 and add them together, and since these are the same signal, you can see this is twice the amplitude because they're adding up. However, if I shift the signal, you can see how that actually ends up flattening it out. And actually how I'm shifting the signal is just by changing the frequency slightly to start the second one moving. So you can see if I set the frequency differently, we have the same effect where the amplitude is growing and shrinking, but now you can kind of see why that's happening as these add together or subtract. And then another cool thing about this, let me just set that to, let's get those back in line. There we go. I can also plot this x versus y with versus. And now what you'll see is x and y are always the same, so we have a straight line. But if you're familiar with geometry, you know that sine and cosine, if you plot one on the x-axis and one on the y-axis, you'll get a circle. And cosine and sine are just 90 degrees out of phase. So if I move this to 90 degrees out of phase, right about there, we have a circle. I can change the sensitivity to make that a bit more round. And if I continue to let that move, you can see how it becomes flat again. And it actually just kind of looks like a ring that's rotating, which is pretty cool. So I just thought that was, a little bit more of a clear visualization of what's going on. And I guess to wrap this up, let me set this to a very different frequency. Well, one that creates a kind of a pretzel design, which is actually really cool. But let me put this back on addition. And you can see you get this warbling pattern that's very rough. But if I set it to twice the frequency, you can see how this always lines up with that, which is kind of cool. So these peaks always line up and the troughs always more or less line up. It's a little out of phase, but you can see how that creates the two separate peaks down here. And just a side note, so the two waveform generators I'm using are the HP 33120A. This is pretty ubiquitous. It became an Agilent product, and then later a Keysight product, because Keysight spun off of Agilent, which spun off of HP. These are even old, they're pretty expensive. And this one is a JYE Tech FG085, and this is a pretty nice little waveform generator. It can't sync much, or can't source much power, but it generates nice waveforms, and it's a DIY kit that you can solder together, and it's pretty cheap. So if you want to get into this, you want to learn how to solder, this is a good kit that gives you a nice tool. And this is what I used before I got this, so I definitely do recommend it. But yeah, they also have some oscilloscopes that you can put together too, which are pretty nice. including a handheld one that's now has a battery built in. So, yep, that's about all I have to say. So, hopefully that makes things a little bit more clear, and also it kind of ties in geometry.